So, hi and welcome everybody. Welcome back to the course of computer networks. In today's lecture, we will continue from where we left off last lecture. As far as I remember, we started talking about multiple access protocols. And I remember we talked a little bit about Aloha and the different types of Aloha, including pure Aloha and slotted Aloha. And we explained the differences between them. In today's lecture, we will continue talking about the other protocols, mainly about carrier sense multiple access. So I believe we covered this material last lecture. We gave you a brief introduction about multiple access protocols and why we need them, including random access protocols like Aloha, carrier sense multiple access, carrier sense multiple access with collision detection, with collision avoidance, or without any of them. And we also talked and explained briefly controlled access protocols, including reservation, polling token passing, and channelization, including frequency division multiple access, time division multiple access, code division multiple access, orthogonal frequency division multiple access, and non-orthogonal multiple access schemes. We said that FDMA was used in the first generation of wireless mobile handset. In 80s, it was used with analog devices. TDMA was used along with FDMA in 2G, GSM we call it, GSM networks. CDMA was used in 3G networks. OFDMA is being used right now by 4G and is expected to be, it's actually being used as well in 5G technologies. OFDM is the only technology that has been used in two consecutive generations, in 4G and 5G, which was out of the norm, was unexpected. And NOMA is a technique that was recently introduced by researchers, and companies are investigating it. They were looking at if they can use it in 5G or not, and unfortunately they reached to the conclusion that they cannot use it in 5G because it has many issues, and we cannot adopt such a technology which is not mature enough until we solve all the issues that are belonging to its operation. So these are the main things we talked about. We explained Aloha, I believe, with visualization, with diagram, explained the properties and features of it, then moved on to pure Aloha, how it works and the features and advantages and disadvantages and how much the efficiency, the maximum throughput you can achieve with it. And then we said that the efficiency of pure Aloha is not that good, and in order to improve it a little bit more, researchers came up with something called slotted Aloha. Slotted Aloha improved the efficiency more by reducing the probability of having collision. And Aloha and slotted Aloha were the first protocols that used to manage the access to an internet network. This is how the internet was functioning in the old days when it was emerged. So these are mainly the protocols that they were using at that time. But later on, more sophisticated protocols had been proposed by researchers, and they started using these protocols in modern networks like the computer networks we have right nowadays. So one of the protocols that's still being in use is carrier sense multiple access. So carrier sense multiple access is used in Ethernet and Wi-Fi networks. So it's a very common protocol, and because of its commonality and its widespread, it's a very famous protocol. We need to study it extensively and understand all the details related to it so that we understand how computer networks work, and we can analyze and understand the content of each Ethernet packet that's being transmitted or communicated over a wired medium or wireless medium. So what are the objectives of this lecture? Mainly, we need to know the various multiple access protocol, understand carrier sense multiple access protocol, then learn the different types of carrier sense multiple access, and then understand the behavior of three main methods related to carrier sense multiple access. So if you look at the general diagram that we have shown you at the beginning of this lecture, we have three different three different multiple access protocols. The first one, random access, controlled access, channelization. So in this lecture, we are talking on this about this part, carrier sense multiple access, which comes immediately after Aloha. So hopefully we can talk about all the other parts later on, but those are the most common protocols that are used in computer networks. Those are mainly used in computer. Those are also used in computer networks, but the other ones here mainly used in like Wi-Fi, wireless, mobile networks. So here you move on to more, yeah. When you go to channelization protocols, you kind of talking about mobile networks. You don't talk too much about really the Ethernet network, the computer network, the wired network. FDM, TDM, CDM, OFDM, all are access protocols and techniques that are used mainly in wireless networks, not in wired networks. Although TDMA is also used in wired, like the mobile telephony is using TDMA, but like in general, I'm talking here. So let's get to know what carrier sense multiple access is, because this is the main purpose, the main theme of this lecture. So what's carrier sense multiple access? So carrier sense protocol. The main goal of developing this protocol is to minimize the chance of having collision while the nodes are transmitting their data to each other. So the principle of carrier sense multiple access protocol is very simple, very straightforward, not too complex. Any node that wants to access or send data over the channel, the node must first sense the channel to see if there is anyone transmitting or not. If the channel is idle, then send. If it's busy, then back off. Then how this procedure is exactly happening, there are multiple protocols coordinating this and responsible for determining how much back off the node should take, and how it should sense the channel, how it should listen, when to talk, and the time and the probability. And these different features and different properties of the protocol result in developing new protocol and a new method that's different from the previous existing ones. So let's talk about now the main terminologies and the main technical terms that you may face or see while you are talking about carrier sense multiple access. So we understand that the purpose of building this is to minimize the collision between nodes. This is easy. The second thing is the principle of carrier sense multiple access is straightforward. Sense before transmit. If you have data, don't just transmit it randomly to the network like Aloha and pure Aloha and distorted Aloha. Whenever you have data, you just transmit it blindly without sensing or knowing whether the channel is idle or not, busy or not, someone is talking or not. I tell you always, if we sit all together in a room and all of us start talking at the same time, then collision is inevitably gonna happen. And it will cause interference. Nobody's going to understand anybody. And the communication in this case, we call it ineffective communication, because everybody is interfering with everybody and nobody getting his message clearly, successfully understanding what the other one wanted to talk to him or wanted to convey to him. So that's why these multiple access protocols are key to make sure that everybody understands everybody, without causing any interference, without causing any corruption to the data, while also utilizing the channel, the available bandwidth, with the best efficiency possible. So this is the main goal of multiple access protocols. We should never ever forget the main goal, the main purpose of this. And all these things are happening at the MAC layer. The MAC layer is the mastermind layer behind the coordination and organization of all these protocols. So carrier sense, when you read the word carrier sense, what do you understand? Carrier sense means I have to listen to the medium that I want to transmit over, whether it's busy or idle. If the carrier busy, it means that the a transmission of a node is taking place, and therefore I cannot transmit now, because if I transmit, I would interfere, and therefore my packet, the energy of the packet is gonna be lost. My data is not gonna reach the receiver, and I need to retransmit again, which means that I will exhaust more power and cause more delay, and therefore the overall performance of the system is not gonna be desirable. Therefore, this carrier, when the carrier busy, which means that a transmission is taking place, no node should take the decision of transmitting when the channel is busy. Here we call carrier busy because our data is usually carried over a sinusoidal signal carrier, and the nodes in computer nodes or mobiles or PCs or whatever, they have some mechanism in their network interface card that can detect if the line is busy or not by measuring the power in the line. If the power is above certain threshold, it means that the carrier signal is carrying certain data. Because to understand it, you just need to visualize yourself when you are talking to via your phone. When you talk to your phone, you feel that there is some energy next to your ear, and you feel that there is some heating. This heating and this energy is coming from two things. First, the carrier that's carrying and transmitting the data forth and back to you. Second is the battery, the energy generated by your mobile phone, and the power in order to push your data and be transmitted over the air or over the medium. So this is what it means to have a busy carrier. When the carrier is idle, when you see the word carrier idle or carrier is idle, it means that no transmission currently taking place in the medium, and therefore you can transmit your data if you have any data, or some other node can transmit its data now. The possibility of collision still exists, even if you sense before you transmit and listen before you talk, because of propagation delays. We all know this problem. We studied it in previous lectures, and we calculated the propagation delay, the effect of it in the performance, and why this can cause collision. Because a station may sense the medium and find it idle. A station, a node, the PC computer can sense the medium before it wants to before transmitting, and it might find the medium to be idle only because the first bit sent by another station hasn't yet been received. So imagine you are sensing the medium is idle, you feel nobody transmitting, but at the time of sensing the channel, there was exactly another node that's transmitting just right now. And you think that you get the assumption that nobody's transmitting, and once you start transmitting, you see that there is a collision happening. Why? Because at the time of sensing, there was a node preparing to exactly transmit at the same time. So the bits transmitted by that other node were not yet released to the medium or to the wired line, and therefore the first node was not able to detect them. So although this mechanism of sense before transmit or listen before talk can mitigate collision, but collision can still occur because of propagation delays and some other issues in the network. So this is the main idea of carrier sense multiple access. Now let's talk about the different types of carrier sense multiple access. Each one we have different types of CSMA, and each one of these has its own properties and its own features. Those properties and features basically determine and define how the node should access the medium, when and what it should transmit, and where and with what probability and at which time. So all these details result in having different protocols. So we have the first protocol, the first type of CSMA is one persistent CSMA. The second is p-persistent CSMA. The third is non-persistent CSMA, and the fourth is O-persistent CSMA. So what are the differences? Let's just take one by one and understand their meaning and what we mean by these protocols. In addition to the above ones, we have the carrier sense multiple access collision avoidance, which is used in Ethernet cables, in Ethernet cards, and carrier sense multiple access collision avoidance, not collision detection, collision avoidance. Collision avoidance is usually used in Wi-Fi networks and wireless networks. This is how we because it's more suitable to the environment and the features of the network. Never ever forget collision detection with Ethernet wired cables and collision avoidance with Wi-Fi and wireless devices. So let's talk now about one persistent CSMA. What's it and what do we mean by it?